Welcome to True Projects. In this video, we are going to explain about the project which is CCG YOLOv7, a wood defect detection model for small targets using improved YOLOv7. Before getting into the execution, first let us understand what is the project about. So we all know that, right? Wood flooring as one of those premium choices that everyone loves in the home design. It is great, it's durable, and it is also eco-friendly, which makes it pretty attractive to people. With its rising popularity, especially in the furniture market, you would think it's ideal material, but it does have its own challenges. So here the thing is, wood floors aren't perfect. When they are being made, they can end up with small defects such as knots, scratches, and mildew. For instance, coming to this knots, so knots are those natural imperfections in the wood grain that can sometimes look nice, but too many can ruin the uniform look people want. Then coming to the scratches. So scratches might happen during the production, handling, or even transportation. And no one wants a floor that already looks worn. Coming to the mildew, it is another one. It doesn't just affect look but also compromise the wood's durability. So if these flaws goes unnoticed, they can lower customer satisfaction as no one wants a floor that doesn't meet expectations in appearance or durability. For businesses, undetected defects lead to higher costs due to rework or wasted products. Early detection is key to ensuring high product standards, keeping customers happy and reducing expenses. So traditional non-destructive testing has been used to detect defects in wood without causing damage. Common methods include manual inspection, electrical testing, scanning, and ultrasonic techniques have been used. So these methods come with significant drawbacks. They are costly, they require skilled operators, and they are influenced by environmental conditions like lighting and temperature. As a result, while effective, they may not be practical for large scale industrial applications that demand quick and reliable results. With the advancement in the technology, computer vision and also deep learning have significantly improved the defect detection. So deep learning and also the computer vision have been prominently used nowadays. Researchers are now able to automatically identify flaws with the high accuracy. However, there are many limitations with these also. So, despite the progress made, there remains a challenge in effectively spotting these small defects in wood surfaces. So deep learning models, including popular YOLO models, they still struggle with the small, irregular defects. These tiny imperfections are difficult to detect because they lack a consistent shape or a size and also they appear randomly on the surface. So to tackle the challenges we face in detecting those small defects in the wood, this project introduces a new model called Cascade Center of Gravity YOLOv7. So this project introduces a model called Cascade Center of Gravity, that is YOLOv7, that is CCG YOLOv7 for short. This model builds upon the existing YOLOv7 architecture but makes some important enhancements to better detect these small imperfections. One of the key changes that we have made is the feature extraction process. So we have added some feature extraction process. So this helps the models to focus more on the details that matter when it comes to spotting these tiny flaws. So we have also introduced innovative components like center efficient layer aggregation networks, that is CELAN, that is center efficient layer aggregation networks, or CELAN, and a new technique called cascade center of gravity batch normalization. So we also have introduced cascade center of gravity batch normalization. So these updates are designed to boost the model performance, model accuracy when identifying different types of defects in wood floors. By improving detection capabilities in an industrial setting, we are aiming to enhance the product quality overall. In the end, this should lead to happier consumers who get better quality flooring that meets their expectations. To further improve the detection ability in detecting defects of the wood, we have taken step further by using the latest advanced versions of the YOLO model, that are YOLO V5X6, YOLO V8 and YOLO V9 as the extension of the project. So these updates allow us to conduct a more thorough analysis and effectively identify defects on the wood surfaces. We also have created a user-friendly front end using Flask framework. So this frontend is designed for easy interaction, enabling users to test the system and explore the defect detection capabilities. We included the authentication features to ensure secure access, making it a practical tool for users who want to analyze wood defects. Overall, this extension aims to enhance to make the detection process more accessible and efficient while providing accurate results. Moving on to the implementation of the project, we have followed the steps in the flow of work to implement. So first, we load necessary libraries and frameworks needed for image processing, machine learning, and web development. And then we load the dataset, load images from the dataset for analysis, and we display the images to visualize the dataset and understand the defects in present. And we do some basic image pre-processing where we transform the image into blob format to prepare it for the model and specify the class defects that the model will identify. And we set up bounding box around defects in the images. And we change the image data into a NumPy array format for processing. And we load pre-trained architecture of the YOLO model and identify the layers will provide the output for defect detection. Coming to the further step, that is image processing, we combine the images with their combined corresponding annotations for training, and we change blue, green, red color format of the images to red, green, and blue, that is BRGB, to match the model requirements. And we generate masks for the defects to aid in detection, and we adjust the dimensions of images to fit the input size of the model. And we introduce some randomness to the images for better model generalization. We also rotate images to create visualizations variations for training. And we apply other transformations like flipping or scaling to enhance the dataset. And to ensure all necessary packages are installed, we ensure that all necessary packages are installed for the project. Format and prepare the data specifically for the YOLO model architecture. So we will be needing some basic requirements for the specific YOLO format. So we will be installing them. So we will be processing based on that. And we construct the YOLO model with the required configurations. And the train model on the dataset allowing we will train the model on the dataset allowing it to learn the defects. Then we select the best performing model. We will save the train model so it can be used later for the defect detections. And we have created the front end web interface of front end using Flash framework, which includes user registration and login functionalities with the SQLite database support. Moving on, in the front end, users they will be able to upload the wood images for the detection purpose. That image will be pre-processed at the back end and it will be fed with the train model. Finally, defects will be displayed in the front end. Moving on to the algorithms used. These are the algorithms used in the project. So this is the proposed model and these are the extension models. So we have used all of them to detect the defects. The model which will perform best among these will be selected for the front end purpose to detect the defects. Moving on to the requirements, we need basic hardware and software requirements. So coming to hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now let us execute the project. To execute, we need to open the code folder which contains source code files. So let us open the code folder. So these are the source code files in the code folder of the project. In the sample folder, here we have the images that we will be using as test cases in the front end to detect the boot defects. Get back. Here in the static folder, this folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. And coming to the app.py file, this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. So this is the model file which contains the algorithm information and this will be loaded into the project code during runtime of the application. And here we have notebook.ipynb file. This file is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. Now, here in the first four folders, we have the data sets. So let us open the first folder, that is wood surface YOLO v6 folder. Here we have two subfolders. One is images and the labels. In image folder, we will be having the images that are used to train the models. And here in the labels folder, we have label files that are annotations for the corresponding images in the images folder. So let us open first images folder. Here we have two more subfolders. One is train and the other one is valid. Let us open the train folder. So these are the images used to train the algorithm to detect the wood defect. So total here we have 781 images. So for these images, in the labels folder, in the train folder, we have the annotation files. So in this label folder, we have files containing annotations or the labels for the objects in the corresponding images. Here, each label file corresponds to an image file in the image folder, providing details about object locations and classes within the image. For example, this first file, annotation file in the label folder of the train folder is correspondent to image in the train folder. So it corresponds to this object locations in this image. Similarly, for the second image in the train folder corresponds to second annotation file of the train folder. So for all the 781 images in the image folder of the train folder, we have total 781 annotation files. Similarly, here we have 780 annotation files in the validation folder for the images of validation folder in images. Get back. In the same way, we have YOLO v5, YOLO v7, YOLO v8, YOLO v9. We have same images, but they have annotation files. They have annotated differently because each YOLO version requires its own specific type of image annotation for training and testing the models effectively. Having separate folders helps keeping the dataset organized, ensuring that each YOLO version receives the correct annotations it needs to function properly. So now let's execute. Copy the path of the code folder from the address bar of the file explorer. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. If you observe here, current directory is changed to the code folder's path. Now we have to compile the app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform runtime check and check for the syntax errors and logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome. So I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. So we need to register first. Click on register. Enter all the registration details if you are signing up newly. I have already signed up, so I'll directly sign in. Click on sign in. Give your username and the password. Click on login. We have logged in successfully and we are redirected to detection page of the project. So here you can see choose file, right? We need to click on that for uploading the images of the wood. So click on choose file. So these are the test cases in the sample folder of the code folder. We will be using them to upload and get the wood defects. So let us upload the first image. Click on open and now click on upload. So here if you observe, here we have three detections. One is live dead knot and two mildews. Live dead knot is bounded with the blue color bounding box. It is drawn in the blue color, navy blue color bounding box, and mildews are drawn in the light blue color bounding box. And here for each defect, it is detected with the label, its own label. That is here, it is live dead knot. It has labeled as live dead knot, and here it is labeled as mild news. And here we have the probability score for each defect, where probability score is nothing but the confidence level. It is how accurate the detection is in detecting that particular defect. So what is this live dead knot? Live dead knots, they are the spots where branches once grew, affecting the wood's appearance. So live knots are still connected to the wood structure, and dead knots are detached and that can weaken the wood. And here we have mildews. Mildews are the fungal growth that appears as staining on the wood, usually in the damp conditions. While it doesn't impact wood strength, it affects the appearance and also the hygiene. Let us upload some more images. Click on choose file. So let's upload this image. Click on open. Click on upload. So here we have a live dead knot detected with the 68% probability score. Get back. So let's try uploading some more images. So let us upload this image. Upload it. So here if you observe, two scratches are detected. So this is the scratch and it is drawn in the white color bounding box with the 0.51 probability score and the other with the 0.83 probability score. Scratch is nothing but it's a surface level defect caused during the handling or manufacturing, diminishing the wood's visual quality without affecting its structure. Let us upload one more image. Get back. Click on choose file. So let's upload. Let's upload this image. Click on open and now upload it. So here if you observe, there are 6 mildews detected and they are drawn in the blue color bounding box and with their probability scores. So this is the mildew defect in the wooden application. So get back. Click on choose file. Let's upload one more from the last itself. So let's upload this one. Click on open and now upload it. So here two defects are detected. One is live and dead knot and the other one is scratch. So this is the scratch and this is the live dead knot. Let's upload one more. Click on choose file. So let us upload. Let's upload this one. Click on open and now upload it. So here also mildews are detected. Get back. Now let's check with the graphs. Click on graph. So here we have precession and recall curve graph. Here each color represents one type of class. Moving on, here we have F1 score graph of YOLO, and here we have confusion matrix. Here we have precision comparison graph. Here we have recall comparison. Here we have mean average precision. So on x-axis we have mean average precision and on y-axis we have algorithm names. Similarly for all the other two metrics also. If you observe YOLO V5X6 model, that is the extension model, is having the highest mean average precision score. Similarly, we have the highest recall and also the precision score. It means that that model is performing well in detecting the defects of wood. Now click on logout. In this phase, as by uploading images to the system that will be processed at the backend and trained YOLO V5X6 model gives the prediction. So in this way, by uploading the images to the application, it will be processed at the backend and trained YOLO model will be giving the defects detection. That means it will be detecting the defects of that particular wood. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.